Hi viewers, welcome to LMS Solution. Today we are going to see about how to measure real and reactive power in the single phase system and the three phase system by using power measurement block in the MATLAB Simulink. So first I'm going to use AC voltage source. First I'm going to explain about a single phase and then after that I'm going to explain about three phase. So first I'm going to use AC voltage source and then we need a load RLC, load series RLC, load, and then I'm going to connect both will be in parallel, both going to be connected in parallel, and here I'm going to fix amplitude will be square root of 2 multiplied with the 230, so I'm going to consider 230 volt RMS with the 50 hertz, and here load I'm going to consider 230 volt RMS 50 hertz, and then this is 5 e power 3 and this is 0. So inductive reactive power is I'm considering 5 kilowatt, capacitive reactive power I'm considering 0, and then active power is 10 kilowatt. Okay. So next we need a voltage measurement block. Just you go to type voltage measurement and we need current measurement. Just you go to use current measurement and connect the current measurement here and connect the voltage measurement across the load, and then here you see that right power block, right? Just you drag and put here and then connect voltage and current measurement. So next I'm going to use scope window. So scope for seeing the result of voltage, current and real and reactive power. So I'm going to use 4 input and layout is 4, and just I'm going to connect voltage, current, real and reactive power. Okay. So next we need a power GI. Okay. And then here I'm going to simulate the system. Now we are going to check the result. So before that we need to do another one thing. So here we need to change the frequency will be 50 Hz. Okay. And now I'm going to simulate again. So you see that right, real power is around 10 kilowatt, reactive power we are getting around 5 kilowatt. So I'm going to add capacitive reactive power around 2 e power 3, and then we will check the result. So now you see that right, total reactive power comes to 3 kilowatt because reactive power, inductive reactive power and capacitive reactive power will be opposite in nature. Okay. So inductive reactive power is 5 kilowatt. So here we are adding 2 kilowatt of capacitive reactive power. So what happened, right? 2 kilowatt will be nullified. Balance will be we are having only 3 kilowatt, right? So but real power will be maintained as it is. Okay. So next I'm going for inductive reactive power will be 0, and then we have to check the result of the system. Now the reactive power will be going for negative direction. Okay. So what does mean? The capacitive element supplying the reactive power in the system. So that's why it's going for a negative. Okay. So now I'm going to adding that inductive reactive power to 2 kilowatt. Okay. Then we have to check the result. So now you see that right, both will be nullified, right? Inductive and capacitive reactive. Okay. So this is about that single phase one. So next we move on with the three phase. So for that we need a three phase controlled voltage source, three phase programmable voltage source. Just go to find out three phase programmable voltage source. Here is that three phase programmable voltage source, and then we need ground, Just you connect this ground here, and then we need three-phase measurement. Okay, three-phase measurement. Just you type measurement, or else you type VI measurement. Three-phase V. Yeah, here is a three-phase VA measurement. Use that one. Now we connect this A, B, C. Okay, and here you can voltage measurement will be phase to ground, and you check this one current measurement also. Okay, so you check whether phase to phase or phase to ground. Okay, that is important. Next we need RLC load, that means three phase RLC load. Now I'm connect A, B, C. Okay, so next here we need to fix the value first. So I'm going to fix line to line voltage. Phase to phase voltage 400, and then frequency is 50. Same thing, I'm going to consider 5 e power 3 and 0, and here I'm going to fix the voltage. Frequency is 50 hertz, voltage is 400. Okay, so next thing it comes to here, and then you will see the positive sequence measurement, right? Just you track and put it in here, right? Just to connect voltage and current. You take this one, measure voltage, current, and then real and reactive. Okay, so now I'm going to simulate this one. So you see that right, three phase voltage and current. Then here you will see that right, we are getting around not, that means here we need to fix 50 hertz and simulate the model again. Yeah, now we are getting 10 kilowatt real power and then 5 kilowatt of the reactive power. We try with the 2 kilowatt of capacitive element. I'm going to check the result. Now you see that variation, right? So now I'm going to change 5 e power 3 real power load. See that we are getting 5 kilowatt, here we are getting 3 kilowatt. So now I'm going to change this one 0, that means inductive reactive power 0. So now we can see that right, it going in the negative direction. Now I'm going to make inductive reactive power is 2 power 3, 2 e power 3. Now you can see that the reactive power is nullified each other. Okay, we are getting only real power. Okay, so and also we can see the variation in the phase angle also. So now we are getting only real power, right? So the phase will be same. Okay, phase angle. So now I'm going to increase the, only I'm using inductive nature, then you will get, you will see the phase angle difference also. Now you see that, right? So it will be start 0, but it will be lag begin that voltage. Okay, so I'm going to use only inductive, so capacitive element. So then you will see that phase angle difference between voltage and current. Now you see that, right? Voltage will be 0, current will be lead the voltage. Okay, so you can see the variation in the phase angle also. That's why you can easily identify whether it is lagging power factor or leading power factor. Okay, so these two blocks going to be used for measuring the real and reactive power, the single phase and three phase system in the MATLAB. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much.